Hello everybody. Today we are going to draw the roof system for a steel structured building. In the last video I have uploaded or I have drawn two alternative steel structured building. Here you see the first alternative in which we have got a reinforced concrete structured basement floor, including the reinforced concrete slab floor of the ground level of the building. And we also have worked on a different on the same building, which is also steel, but this time the basement floor of the building is also in steel, or in other words, or if we want to be more correct, what is the main difference between this building and the other one? In this building, the column starts from the top of the foundation and it continues as a steel column until the top level of the building. So once more, I want to correct myself and I want to clearly explain this to you. This thing that we see here is the column, and that column is steel, and it is tied as it is steel. It is tied to the reinforced concrete foundation of the building by the help of the steel base plate. And from the top of the foundation to the top level of the building, it continues as steel. So column is made of the same material, which is steel. Whereas in the other alternative, what do we have? We have a reinforced concrete column starting from the top of the foundation. It comes as a reinforced concrete column until the ground level of the building, ground floor level of the building. And from the top of the ground floor, it continues in steel. Okay, so the material of the column changes on the ground floor level. But don't forget that it is still continuous from the top of the building to the foundation. Only the material of the foundation changes. Now what we will do is, I'm going to do this. I'm going to take a piece of paper and I'm going to stick that piece of paper to last drawing that I have made, because I don't have enough space in my paper. Okay, and I want to obtain a wall section drawing, a full size wall section drawing. In order to do that, I need more space. Okay, now let's move this page a little bit up like this. Okay, and we are going to draw our roof right on top of this one. And let me pull my sheet a little bit down and let's write a couple of definitions here, or a couple of explanations here. So according to the slope of the roofs, we categorize them into two. We have got pitched roofs and we have got flat roofs. And even though we call some roofs as flat roofs, in fact they are not flat, but the slope of them is so little that they are perceived as they are flat. But in fact there's a slope in them as well, because without a slope you cannot make the rainwater coming on top of your roof start flowing and finding the strainer and escaping from the building from the strainer. Or in other words, in order to make a proper rainwater drainage system, we need to give each roof some slope. Whereas the pitched roofs are roofs which is slope is high, and with bare eyes we can easily understand that they are sloped. Okay, and we can have larger slopes, even larger than 30%. Even we can have 100% of slope. Don't forget that 100% of slope is not representing something perpendicular. This is 100 centimeters here, and that's 100 centimeters there, and this thing that is going to be the slope of our roof. Okay, so the angular form of it is going to be 45 degrees, but the percentage slope of it is going to be 100%. Okay, so we can make pitched roofs even 100%, or even we can make them 150% of sloped as well. Okay, which what we cannot do, we cannot make it more than 150% maybe. Okay, it's going to be too steep. Okay, and I choose to make this first roof that I will draw today as a flat roof. And in the lectures we have been talking about flat roofs for a couple of weeks now, and what I say is the number one thing that we need to add to a flat roof is going to be a parapet wall. A parapet wall is going to be a vertical barrier at the borders of our flat roof, which is going to prevent the rainwater coming onto our roof to fall from the edges of our flat roof system. That's something we do not want, because uncontrolled rainwater is going to generate failures in our building. We want to control the flow of the rainwater coming onto a flat roof system. That's why the first thing that we need to do, we need to keep it on top of our flat roof. And then we should not keep it forever on our flat roof, because in that case it's not going to be called as a flat roof, but it will be called as a swimming pool, a rooftop swimming pool. We don't want that as well. That's why what we need to do is, the second thing that we need to add is a rainwater drainage system, which consists of two things. The first thing is a strainer, and the second thing is a downspout. So basically today we are going to see how these are detailed. Let's start drawing. Okay, what we will do, firstly, on top of our tapping concrete, right here, we are going to construct our parapet wall. Okay, like that. What is the approximate height of our parapet wall? It will be something around 60 to 120 centimeters. You don't need to make it longer. Okay, that will be enough. Okay, like this. And then, of course, we are going to apply plaster to both sides of it. Okay, and now that we placed our parapet wall there, let's turn back to our information part of the sheet, and now let's categorize the flat roofs according to the placement of the waterproofing and the thermal insulation on our roof system. We have got normal roof and we have got inverted roofs. Normal and inverted roofs we have. What's the difference between them? In normal roofs, let's take some colored pen. In normal roofs, we have the thermal insulation at the bottom, and we place the waterproofing on top of it, like that. And in order to prevent the condensation risk, we place a vapor barrier underneath the thermal insulation. Whereas in inverted roofs, what we do, we use the waterproofing on top. So now that waterproofing is a double acting thing, it's acting as a vapor barrier and a waterproofing. And we are going to use our thermal insulation on top of our waterproofing. Okay. Here the critical thing is this: the thermal insulation will get wet. So it shouldn't absorb water in it. And there are not too many alternatives now. We will probably use an extruded polystyrene thermal insulation material. Okay, and let's go back to our drawing. And now what I say is I want this roof to be a which one would you like to do? Let's make it a an inverted roof. Okay, and in the inverted roof, what we need to do, let's write here another thing. The number 3 thing maybe is going to be the slope screed. Slope screed is the part of a flat roof system which is going to make the rainwater start flowing when it touches to our roof system. So what I will do now, as I have a normal roof organization, I am directly going to apply my vapor barrier on top of my tapping concrete like this. I'm going to cover the entire tapping concrete of my building, and I'm going to turn it upside onto the parapet wall. Let's even extend it some more, maybe like dash. Okay, and let's try to understand what a vapor barrier is. It's probably a polyethylene foil which is very commonly used in trash bags. Trash bags are also made of polyethylene. Okay, so if you say that you don't want to buy a sophisticated construction material, a polyethylene foil, what you can do, you can go to a market and buy some trash bags, and you can cover your roof, cover the topping concrete entirely with those trash bags, and they are going to work as well. Don't forget to tape the joints of it, of course. And then what will we do? We are going to place the thermal insulation on top of our polyethylene foil like this. Okay, what is this? That is an that can be almost any type of thermal insulation material, as we will cover it with waterproofing, and that's going to keep our thermal insulation dry. And now that I want to make the rainwater coming on my roof start flowing whenever it touches to the rooftop, what we need to do, we need to cover it with a slope screed. And here's our slope screed. I'm drawing it slightly more sloped than it is in order to make you see it very easily. And what I do is, what I say is not rain, but waterproofings do not like to turn perpendicular corners. That's why, in order to prevent the waterproofing to be folded perpendicularly and crack, in fact, from that fold line, what we do, the end point of the slope screed is going to be sloped to the opposite direction. Okay, and we are going to obtain a slope screed like this. Here I draw it more than it is, more sloped than it is in real life. Okay, and what we will do now, it is time to cover our roof with our waterproofing, and here is the waterproofing like that. Okay, on the parapet wall we stick the waterproofing to the vapor barrier. They are overlapped onto each other right here. Okay, and let's draw our dashed and dotted line here in order to represent that. Roof layers continue that way. Now I need to give a decision. My roof is finished, in fact. I can leave it like that. If I use a waterproofing material which is warranted to be UV resistant as well, we can leave it like that. Okay, it's not going to be deflected from the degradation factor of the sun. But usually what we do when we make or construct a roof like that, we would like to use the top of that roof. Okay? And in order to use that, what we do, we firstly lay a separation layer, which is usually a geotextile felt, and then we cover it with another layer of slopes, another layer of screed. Not a slope one, just normal screed this time. Not too thick, 3 cm will be enough. What we want to obtain a straight plane, straight and arc plane onto which we can stick our finishing material. And onto that screed, what we will do is, by the help of a glue, maybe a cement mortar or maybe a sophisticated ceramic glue, we glue the material, the finishing material, onto our screed. Don't worry, I will write the name of the layers here, starting from the steel trapezoidal sheet. What do we have? The lowest level we have steel trapezoidal sheet, and then we have topping concrete, and then we have the vapor barrier, on top of the water vapor barrier we have got the thermal insulation. Any type of thermal insulation panel may be used here. It needs to be panel. It shouldn't be a mineral wool. If you use, it shouldn't be a blanket. Sorry. If you choose a stone wool panel, even that will be fine. It needs to be panel, which is going to be resistant for pressure. And on top of thermal insulation, what do we have? We have got slope screed. And on top of the slope screed, we have the water proofing. On top of the waterproofing, I have got another screed. And then, I need to erase that part, I guess. Proofings don't like turning corners. Write it in your minds. It's no more on the screen. On top of the screen we have got mortar, which is a glue, in fact, and on top of the mortar we have got the stone tile finishing. Okay. We have got a couple of things left. Firstly, what we need to do is we need to do this. We need to continue our thermal insulation until the top of our parapet wall, like this. Thermal insulation continues, of course. Okay. And what else do we have? We have got the plaster and paint continues until the top as well. And what we do, the top of our parapet wall, let's extend the vapor barrier and the waterproofing slightly more as well. And with a purple pen, what I will do, I'm going to close the top of this system. But before doing that, what I will do is I'm going to use a thermal insulation here as well, like that. Okay, and again I'm going to apply plaster onto it and I'm going to paint it. And now the top of my parapet wall is going to be closed with a coping, with a hat. Okay, a hat which is going to prevent the top of the parapet wall to absorb water whenever it rains or snows on top of it. And this thing's name is going to be a coping. This is a coping now. Okay. And what we will also do, we are going to use here a skirting, maybe something like this, and here is the skirting in section. And what we will do is, in elevation we have the coping continuing like that. Okay, this is how our flat roof is going to look like. Instead of covering our flat roof with a hard plane, with a screed and a stone, ceramic or concrete tile adhered to that screed, what we can also do is we can also leave the roof with waterproofing only, or we can, on top of the waterproofing, place a separative layer. I guess we have forgotten the separative layer here between the waterproofing and the screed. Here we have got a separative layer. Usually whenever we are putting different materials onto each other, we do not want them to touch to each other. Instead we want to separate them from each other by a separative layer, which is 99% going to be a geotextile felt. Okay, I guess it's all about the flat roofs. I want you to complete these wall sections, this type, which has got a reinforced concrete basement level here with a flat roof system like you see there. That's all for now. A couple of minutes later I am going to record another video, and this time we are going to construct a pitched roof over our steel concrete composite deck type of floor. See you later. Bye bye.